you can understand how it might be useful to edit these scaled values because in some cases you'll want a little bit more precision over what it is that you're editing in these maps. And if you never ever rescale your load or RPM axes, you'll basically never have any additional control or any more precise control or any additional resolution in being able to edit your tune. So it may be a problematic when you run into a situation like we mentioned here, where in order for you to be able to confidently say that you've corrected, let's say you have an air fuel problem at the 130 load, 3250 RPM data log point from your data log, you basically have to change 4 cell values in order to attempt to heal that, or you should be changing these 4. So in order to assist the precision of your tune, in order to make it more useful to you, and in order to better make use of the limited amount of space that we have here, we basically can rescale these axes to give us a different set of information to work with. And the other point I'll bring up is that whenever it goes out of bounds of the scales that we've set up, it's basically just going to continue to use the outer bounded values that exist on the edges of the map. So if we go beyond 300 load, beyond 7500 RPM, and so on, we're going to be using these outer values. So it's not necessarily that fuel will continue to will stop flowing after 300 load, but you won't really have any control over it. So it's important to be aware of what your needs are in terms of load and what your needs are in terms of RPM. This is a common oversight of tuners or people who do quick down and dirty tunes that don't really have any interest in giving you any high level of precision over what's in your maps. And they really just want to kind of set it up quickly and get you out the door. So it's sad to see in some cases people just neglect to even care about what goes on in these maps, but you should be aware of it, and you should be able to take advantage of it. Now the other thing that's worth noting is that you'll note that my Evo 9 ROM has a pretty decent sized fuel table, and the timing table is even more impressive in terms of size. You can fit quite a bit of data in here, so you have a lot of space to work with. You have quite a few RPM values, quite a few load values. So it's nice. The Evo 9 is twice as big as an Evo 8 ROM, so they've been able to cram some more information into here. So if you have an Evo 8, you might be a little envious of this, but if you do have an Evo 8, it's even more of an important lesson to learn here as far as rescaling these guys, because you're going to have even less space to work with, so it'll be vital that you understand how to rescale to your benefit. So working off my Evo 9 ROM, let's just kind of take a glance at how it's set up from the factory. So initially we're moving in increments of 10 here across the load scale, from 10 to 20 and so on. Once we get to 100, it's going to start going up by 20s until we hit our upper bounded 300. So let's say, for example, that you've done a bigger turbo upgrade. You're running a significant amount of boost. Maybe you have E85 or meth injection or race gas, and you're exceeding 300. Let's say you're going up to 350 load. So there's a few things we'll have to do in order to maintain a reasonable level of control over your tune once you exceed 300. And the way we'll do that is by rescaling all of these values and then essentially shifting everything that we have below here into new positions that match up with where they should actually be in terms of load. So from the factory, you'll note that there's a lot of information here that seems pretty redundant. I mean, we have a good quarter of the map from the factory is 14/7s, and even the first 4 complete columns of data here are 100% identical. So if there's a spot that you can reclaim some space, this is definitely it right here, because there is absolutely nothing different from column to column in this vicinity here. So given that information, we know for sure that we can cut all this down to even just one column of load. So let's say we're going to shift everything from 50 and up down to this position here. So basically I've just highlighted everything from 50 and up, and I've hit Control C to copy. Select the 20 cell to where we want to move it to, and I'll paste it. So it's shifted everything down. We go from 10 directly to 50, we skip everything in between, and now we have 300 up here. So in order to make it look a little bit nicer, we'll just continue this progression of 20 load increments, and we'll go 320, 340, and 360. So now we've expanded our fuel map to be able to allow tunability into levels of load beyond 300, and we've done that by eliminating all the redundant cells that are below 50. Now if you notice, nothing else happens in the map below, so you have to be careful when you do this, because nothing else gets shifted along with that. So as soon as we change these load values, we're changing the tune significantly. We've made a large jump in terms of how much fuel the car is going to be using. So if we just saved this and flashed it back to the car, we could potentially be in a really dangerous state in terms of fuel, because we haven't made any other corrections in the fuel map below. So you do unfortunately have to go through and figure out what exactly you want to do with this data down here after you've figured out what you want your load scaling to look like up top. So what I've done is I've taken all these values that represent everything from 50 to 300, and I'll do the same, copy and paste. And everything beyond 300 up here, this kind of isn't the exact data we need. So here's another example. If you recall, in our last video we went over the Interpolate function, but here's a great use for it. So for viewability's sake, I'll just get everything as low as possible here. 7.4 happens to be the lowest you can put in a fuel map. And I'll just select everything in 300. That's the highest realistic column that we had from our original map. We didn't have anything beyond 300. We'll go ahead and paste it into 360. We'll select everything in that column, and we'll do an add of -1. So we'll basically make it a full AFR point richer. So after having done that, we can select this entire region, interpolate horizontally, and we end up with a smoothed, richening progression. After we exceed 300, we get continually richer until we hit our safety margin of 360. So if you had a car, for example, that was using 320 or 330 or 340 or 350 load, you know, this might not be a bad place to start in terms of setting up your map to be accessible to the cells that you need when you're cross-referencing your data logs with EcuFlash. So you may want to just double-check your work. You can always save it as something else and bring up the original instance, and then look at the two side by side. I'll do that now just to show you what I mean. If we reopen our original and bring up this fuel map, it allows us to just check our work, and I recommend you do this because the last thing you want to do is make significant changes to your fuel map and have something go wrong. So if we look, we can just kind of do a visual check here. We brought everything starting with maybe 12 fives at the bottom here from 50. That does seem to match up. And we'll do a couple spot checks along the way. At 140 load, we're having maybe 13.5, 13.1 in here. That looks right. And down the end here at 260, which if 140 is good, 260 is probably going to be good. And it looks like it is. So we verified our work visually. I would say this is getting close to being safe to flash to the car. But before we do that, you always have to remember, back in our earlier videos, we touched upon the topic that this scaling lives in a common address, and this is not the only map that utilizes this scaling. So you do have to remember that when you adjust the scaling, other things will be affected. And by other things, I mean the low octane fuel map. So if we look at these visually, we can see that if we flashed it to the car in this current state, the low octane fuel map is actually significantly leaner in most of this map than the high octane counterpart, which in general in a tuned Evo is not what you go for. So we can take the approach of putting everything from the high octane fuel map into the low octane fuel map initially, and doing a very simple, straightforward addition or